Day 2, transformations. I'm going to try and cram in reflections and rotations into this lesson. So let me begin with reflections. A reflection, as I mentioned yesterday, is a flip. To be more specific, it flips across a central line. So in this example, ABC does not have the prime marks. These have the prime marks. So we're starting here and we're flipping to the left. What you would not do is, say you're starting right here, is flip to right there. Why you would not do that is because of reason 3. All right, so let me try and explain that by reading reason 3 to you. It says every point in the pre-image, which this is the pre-image is where you start, every point in the pre-image is the same distance from the central line. The central line is the line that we're flipping across. So every point in the pre-image is the same distance from the central line as the corresponding point in the image. Right, corresponding means the same, basically. So A goes to A prime, B goes to B prime, so on and so forth. So if B prime is that far, or I'm sorry, if B is this far from the central line, B prime will be that same distance from the central line. You flip across the line and end up the same distance away from the line as what you started, just on the other side of the line. And that's kind of what I drew down here. I was going to use this picture to explain what I just did, and say, if this is a distance of 2, then this would also be a distance of 2. All right, you end up the same distance away from the line you're flipping across as from what you started. So those are some more basics I want to say. I mean, really, flip is the basic. That's what reflection means, is to flip across the line. But to be more specific, not just any line, we call it the central line, or the line of reflection sometimes it gets called. And you can't just flip it over here to wherever you want. You can't just say, hey, flip that paper to the other side of the line. Just throw it over there wherever you want. It's got to be real precise. It has to be the same distance from the line as what it started. So if you were 3 away, you end up 3 away on the other side, or 2, or whatever it may be. One more thing about reflections. Reflections usually are the easiest of the 3 because you're just flipping to the other side of a line, the same distance across it as what you started. When it can get tricky is when that line is not a straight line. So let's say it's a diagonal line. Let's say it's this line right here. Well, if it's a perfect diagonal through the origin, that's the line y equals x. That's the name of that line, y equals x. Now let's say you want to reflect this line segment AB across the diagonal line y equals x. It would be the same distance across as it is to the line. So you go straight to the line. So let's say straight to the line right here. I better use it different. There you go. Let's say that distance is 4, then you will go 4 past, and you'd end up right about here. All right, if you connect the B's, it's going to be a 90-degree angle with your central line. That's a little 90-degree angle. You always go straight across it. So what you don't want to do, the reason I'm telling you is that it's a 90-degree angle, is so that you don't end up doing something like this. Okay, this is a distance of 4, and this is a distance of 4. Let's put B prime over there. No, you don't do that. It satisfies what I said before. You go to the other side of the line, the same distance past it as what you were from it. This is 4, that's 4. Hey, what'd I do wrong? Everything's cool, right? No, you got to go straight across that line. You got to go straight to the line and then straight across. So you'd end up here. All right, you can't crisscross. You can't draw your line like this up here and say this is A prime and that's B prime. That would be a no-no. That would be wrong. That would be crisscrossing. That would be saying going straight, going to the line, like that would be like crossing like this. reflections don't crisscross. The lines, if you connect your corresponding points, they're always going to be parallel. All right. So if you connect B to B prime and A to A prime and those lines cross, you did something wrong. You switched up your points over here. This should be B prime, that should be A prime. So now when you connect B to B prime and A to A prime, those two lines are parallel. That means you went straight across. That's what you want. All right, don't crisscross your A's and B's there. Go straight across the line. And you could come up with a bunch of different diagonal lines that you could potentially reflect across. You could reflect across this diagonal. That's y equals negative x. You could have, say, this line right here, AB. If you want to reflect AB across the diagonal y equals negative x, it would be, let's say that distance is 2. Let's go 2 past. I'm terrible at drawing this little shape. So let's say that's 2. That'd be your prime lines. Would this be A prime or would this be B prime? It would be A prime. Because A was distance of 2, A prime is a distance of 2. This would be your B prime up here. All right, so not so bad. Just remember, you can reflect across the diagonal. Just don't crisscross your points. So let me move on to rotations. Rotation, as I said yesterday, is a spin. And you can spin something, don't say left or right, it's as the clock spins. Clockwise would be what you would call to the right. The clock is pointing at the 12, it spins towards the 3. That's clockwise. Or you could spin counterclockwise, the opposite way the clock goes. The clock is pointing at the 12, you spin towards the 9. That's the opposite way the clock would go. That's counterclockwise. So clockwise would be going from A to A prime. You would be going from here down to there. And counterclockwise would be, say, A starts here, A would end up over here. Now, what I just did there was rotate in 90-degree increments. So that's what that means. All we're going to do is rotate things in 90-degree increments. That means we could also spin it 180 degrees. That's an increment means multiples of something. So at 90 degrees, 180 degrees, 270, 360. If you spin 360, you're all the way back to where you started. So a rotation of 360 degrees just puts you right back where you started. It's like you didn't even move at all. Rotation to 90 degrees is going from the 12 to the 3 or the 9. 180, doesn't matter if you spin it counterclockwise or clockwise. If you spin clockwise 180 degrees, you're going to be going from the 12 to the 6. If you go counterclockwise, you're going to go from the 12 all the way to the 6. You're going to end up at the 6 no matter if you went clockwise or counterclockwise. So we don't really give a direction for 180 degrees because either direction, you could go either way and you're going to end up at the same spot. All right, let me give you a little bit more detail on some rotations here. This looks a little crazy, so let me explain it. We're starting off here. This is the only triangle that does not have prime marks by it, so that's our starting point. If we rotate this 90 degrees clockwise, we end up down here. Clockwise rotation, well, is spinning the way the clock spins. So to really go farther in depth on the clock analogy, you need to know where the center of the clock is. These points would be the ends of the hands of a clock. In this particular example, the center of the clock is right here at the origin. So if this is a hand and my hand is pointing all the way to the A, I would spin 90 degrees clockwise like this, and it'd be right there at this A. Maybe a ruler, something longer would be better for this, but I don't have a ruler in front of me, so sorry about that. Maybe I can go miniature style. So here's my pencil cap, my pen cap. That is the hand on my clock. The clock, the center is right here. The hand is pointing somewhere in between like the 1 and the 2 on a clock. If this was a giant clock going through the A's, this would be my 12, my 3, my 6, and my 9 on my clock. This is like perfect 45-degree angle. It's right in between the 1 and the 2. When you spin 90 degrees, you always spin 3 hours on the clock. Every 3 hours on a clock is 90 degrees. So if we're at 1:30 right here, we need to go to 4:30 right here. That's 3 hours. 4:30 is exactly in between the 3 and the 6. So the A goes 90 degrees to A prime. The opposite would be counterclockwise. What's 3 hours behind 1:30? That's right, 10:30. Exactly in between 9 and 12 o'clock. So you would spin counterclockwise. A would go this way to A prime 90 degrees. And if you spin clockwise, it would go this way to A prime 90 degrees. Now, if you spin 180 degrees, it ends up exactly across from where you started, whether you went clockwise 90-90 or counterclockwise 90-90. So 180 is always straight across from where you started, and 90 is just 3 hours. All right, so straight across would be like 6 hours. Now this can get a little tricky here, because let's say we look at the C. Say this is my clock hand. The C, what's straight across from the C? Right there. This C, they're straight across from each other as far as the clock goes. Now we're not going across the central line, we're spinning that clock. So if we were to spin this clock 6 hours, it would point right here. Now, when I had the example before for reflection and we were spinning across the line y equals negative x, say this line right here, now we went straight across the line y equals negative x. So A would have went straight across to here, and C would have went straight across from here, and those two lines would be parallel. So this would actually be A prime, and this would be C prime if it was a reflection across y equals negative x. But if it's a rotation, like I'm showing you here, then our lines actually crisscross. C goes to C prime, and A goes to A prime. Now our lines have crisscrossed. I wish, there you go, now you can see that better. Does that make sense to you? That's like the key difference that's hard to understand with rotation of 180 degrees and reflecting across the line. Some people will look at this and say this triangle goes to that triangle, and they won't know, was it because of a rotation of 180 degrees, or was it because of a reflection across the line? And that's how you tell. If you connect your corresponding points, like your A's to your A's and your C's to the C's, if they cross, if those two lines cross, that was a rotation of 180 degrees. That's spinning your hand 6 hours. If they don't cross, if this is C prime and this is A prime, then it's a reflection. Now you just flipped it straight across there. So let me try my little handy dandy piece of paper that I cut out. All right, here's our line y equals x. Here's our shape. I'm going to reflect that across this diagonal line. And you can see when I reflect it, it goes like this. I should probably start on the front. So this will be the front. Reflect it to the back, and this corner went straight across. That's cut out. It went from up here to over here, straight across. Now, if I rotate it, it's going to rotate once, twice. Now my corner's down here instead when it was up here before. See, the corner's down here. I rotate it, now it's up there. It's not straight across. Maybe I should outline it. So we're starting right here. I'm going to rotate it 180 degrees, 90, 180, and now my corner that got cut out is over here. If I connect the corresponding points on my corner, they crisscross. That's a rotation. Now, if I reflect it, if I just flip it across, here's my piece of paper. If I flip it across, it looks like this. Now my corners that I cut out, this connects to there and that connects to there. They don't crisscross. That's a reflection. So hopefully you understand what I'm saying there. I know this isn't the most pretty video, but that's why I teach reflections and rotations together, because they're kind of, because of this right here. This is a tricky one. Is it rotated 180 degrees or is it reflected? That's how you tell. Connect your corresponding points. If they're parallel, it's a reflection. If they crisscross, it's a rotation.